Okay, let's start some physics. So we are now journeying into outer space in order to avoid a lot of extraneous influences that are present for us here on Earth. And the text begins that we are in a bubble floating in outer space somewhere. And so we are going to do, being nerds, physics experiments in this bubble, which will allegedly simplify our lives. So let me start with a really impressive demo. Let's see if I can do it from the back. These are, apart from some decorations on the end, nominally identical. Did you notice that the velocity after the collision was exactly half the velocity?
Try it again, try it again.
Yeah, watch it carefully. See? All right, let's see if we can quantify this a little bit. Yes. Okay, so now I have to wake up. Okay, floor box 2, go to the left. Ah, there we are. Okay. So let's see if we can play this movie here. See? So I shot this very fine, high precision video, and then I went along step by step, marking the position of the left cart at various intervals of time. And the result is that graph. Now you can see my tapping skills kind of suck. So there's probably a lot more waviness in the position, which is shown here as a function of time. This one down here is the velocity. So how would you go from this set of data to this set? Is it, well, wait a sec. These are discrete points, right? So at selected intervals, I'm tapping on the screen, and it's recording the time in the movie and the position where I've tapped. So how would it go from these data to these? Yeah?
You would take a picture of 2 different places, or take 2 different taps, and the amount of distance that's traveled over the amount of time would be the calculation you would make for where the next point would be.
Yeah, okay, so I think if I understand correctly, so this point is demonstrating that I have Parkinson's. But besides that, this point is the first tap. So that was the position of the front end of the cart at 1 frame in the video. And then when you tap it, it advances to the next frame, or it goes a few frames, and I tapped again. So it now knows the time interval, right? The time interval we read off of the horizontal, and it has a second position. So given those 2 numbers, how is it going to go and try to find a velocity? What would you do? Look it up on Wikipedia. Is that true? Yeah.
Take the difference between the 2
Yeah.
locations and divide them by.
Yeah, so what if we were to take the amount of change in the x position and divide that by the amount of change in time, delta x over delta t. That's an approximation to the instantaneous speed, isn't it? It will give you the average speed over that interval. Do we agree? So the average speed would be the interval in x divided by the interval in time. And we could use that to build up the graph at the bottom. Do you agree? So as you can see, just as I advertised, here before the collision, we're at, how much is that? What is that? Negative 500. Something's per second, yes. Pixels per second. And then afterwards, we're at exactly 250. See, do you see that? Do you see how exact that is? Of course you do. All right, so then we could try another experiment where I have two identical and I send in one. Now what should happen? So if what you saw is this is moving so the speed afterwards 1/3 of the speed of the incident rider. So I'm going to pretend that I'm done with those demos and get on with life.